So once again, good evening everyone. I'm Elsa from NIT-Tiruchirappalli. So today we'll be looking at week 7 assignments. So in this week we had looked about classification as well as regression. Yes, good evening. Yeah. So first now we'll be looking at the assignments of week 7 of last course. So I have included previous course as well as the course before that. So we'll look at the questions and simultaneously we will be looking at the RStudio implementation also. So the first question is to load the dataset iris.csv as a data frame iris_data with the first column as index headers, first row as column headers, dependent variable as factor variable, and answer the following questions. Okay, so iris data, as you can see, is it contains of 4 sepal and petal features and of 50 equal samples of 3 different species of iris flowers. Okay, so we'll just move on to the RStudio implementation. So first what we'll do is that we'll first read the data to iris_data as was given, and then we will see the different questions. Okay, so first thing is like what are the dimensions of the data frame. Okay, so first we have to load that. So for loading that, it is a CSV file. So because of that we'll be loading it. So you can see here, this is iris.csv. okay, this is iris.csv. so you can see here the ID, sepal length, petal sepal width, petal length, and petal width is there. Okay, so this is the data that we'll be loading, and so that is the data, and this is present in this particular path. Okay, so what I am doing, there are many ways of loading. So first I will do like this. Okay, I have given the path here and the name of the file, and then I have given header equal to true, meaning that the first, so I think you have seen here, the first row is the header. So header is taken as the first row, and then rows.names equal to ID. So ID should be taken as the row names, and strings is factors equal to true. So it will be stored as a factor. Okay, so the strings which are available will be stored as factors. Factors means that it will be stored as the different categories which are present in the data. Okay, so first we will read this to iris_data. So here you can see the ID number is taken as the row names as we have said, sepal length, sepal width, petal length, petal width, species. Okay, so here you can see anyway placing on the column name will give you what is the column type. So first one you can see it is numeric, second one also numeric with range is given, third numeric with range 1 to 7, then fourth also numeric, the fifth one you can see it is a factor. Okay, so this is because we gave that specific condition that the strings should be converted to factors. Okay, otherwise it would have taken as a character variable. Okay, so now here we have given strings as factors equal to true, that's why they are taken as factors. So factors, as I said, means that they are taken as categories. So if you see how many categories are there in this particular data, you will be getting like, so here you can see setosa, versicolor is another category, and virginica is another category. So you will be seeing those 3 categories. Okay, so first we will see the dimension. So first when you get a data, you can see the dimension, then maybe the summary to get some information about the data, then str of this data. So that we have done earlier also, str of iris_data, if you do, you will be getting what are the different data types of the data frame that we have created. Then likewise many things you can do, like the head, tail, sample, etc. So first question was anyway, what are the dimensions of the data frame? So we'll come back to that. So dimensions of the data frame are, you just have to give dim of iris underscore data. So you will be getting 150 comma 5. That is the dimension. Okay. Now the second question is, what can you comment on distributions of the independent variables in the data frame? So I think dimension is clear. About the second question, can you tell me what they mean by the distribution of the independent variables? Or first, can you tell me what are the independent variables in this particular data? You can see the column names here. Maybe you can just tell 1, 2, 3, 4 to tell about the independent variables. What are the different independent variables there right now? You can just tell me a name, like sepal length is the first column. So first, second, 3, 4 or 5. Okay, you can name like first column. So you can just tell me which all columns contain independent variables. Petal, sepal length and width. Okay, that is fine. And yes, 1, 2, 3, 4. Okay. So in this one, we have to comment on the distribution. So how can you, do you have any idea to see the distribution? How can you see the distribution of this plot? By the way, is it visible? This should I increase the size or anything, or is it visible? I hope it's visible. Okay, if anything, I can increase the size. So anyway, you tell me. So just if you give the summary of iris underscore data, this is what is coming. So okay, so this is what is coming in the, if you give summary iris underscore data, as we have seen earlier, minimum, first quadrant, quartile, median, mean, third quartile, max, everything will be coming. Okay. So one way, like to see about the distribution, one way you can see is, see how the median and mean are distributed. Okay, how is the mean and median? Okay, so what I'll do is, I'll just come back to the thing. Okay, so just for the second question, I'll just use this. Okay, so you see here, this is like, okay, this is the 0th point. My distribution of data looks like this. Okay, so this is like this particular point. Okay, see that it has the mean 0 and variance, I mean the sigma value falls, minus sigma falls here and sigma falls here. Okay, so what kind of a distribution is this one? Okay, yeah, you can say that it is normal. Okay, one Pavitra is telling all variables are normally distributed. Okay, so okay, you can tell that this is a normal distribution. Okay, this is kind of, okay, the shape looks like that. So this is like, if you have the distribution like this, okay, still it's a bell shape, but it is skewed in the left side. Okay, and there is another way when your distribution can look like this also. Okay, so this is like left skewed and right skewed are there. Okay, so how can you find it is like just seeing the distribution of the plot. Okay, one of the ways is like you can plot the variables and find out whether they are distributed like that, or another way is like to watch the mean and median. Okay, so what you can observe is that, so if the mean and median are close, okay, so the difference between the mean and median is very less, it's most probable that your data is distributed normally. Okay, and if there is a considerable difference between the mean and median of the data, then it is not normally distributed. Okay, so just we'll come back here. So first you observe this one, median, mean. Okay, both are like 5.8 and 5.843. okay, you can say that sepal length is not having much difference in that median and mean, so it is normally distributed. All right, so sepal width also kind of. Okay, now look at the petal length. Petal length median is 4.350 and mean is 3.758, and for petal width it's like this, and species, anyway it's a category. Okay, so this is one way, so you can directly say that these two are normally distributed. Okay, so in your options what was given was all variables are normally distributed, so that won't be right. Okay, because one of your variable is showing a great difference, so that won't be true. Then the variables sepal length and sepal width are not normally distributed, so but you can see they are normally distributed. Okay, so that is true. The variable petal length alone is normally distributed, that also is not true. So for this question the answer will be like none of the above. All right, okay, I hope this is clear till now. And this is one of the methods where you will fill the missing values also. So whenever you come across one type of data, and you should first look at the distribution of that data for that particular column. Okay, so if the distribution is normally distributed, then you can fill the missing values. I mean, this is the basic methods for doing that. So you can fill it with the mean values, but in case you have some skewness in your data distribution, then you should go with the median. Okay, so that is one of the ways. But here now we will see another method to see how this data is distributed. Okay, so right now we have seen the summary. So from the summary we have seen the median as well as the mean. Now we can see a pair plot also. Okay, so for pair plot, can we draw with the given data? Yes, we can draw that. So with the given data you can draw that. So for that it's better if you install these two libraries. Okay, so if it's not present, you can use install.packages, this particular name if you know the name, or otherwise just search for the name how to plot pair plot. Okay, so one way you can see the distribution is like with a pair plot. Okay, so for that these libraries need to be installed, so I will install those libraries. And what I have to do, this is the command you have to give, gg pairs of iris underscore data. So I will plot that here, and I need to increase this window. Okay, or okay, this is the image. Okay, I think the image is visible. So you can see here sepal length, there was like here when you saw there was some differences there, so but still it is having a normally distributed curve. Okay, sepal length. So how to understand this pair plot is like, here what they will do is like sepal length versus sepal length will do. Okay, how in this particular plot, in the pair plot, I don't know if you have seen pair plots earlier. So pair plot is something where you can see the correlation between the variables as well as how the variables are distributed. Okay, so in this particular plot you can see that sepal length. Okay, so all the columns sepal length, sepal width, it's present here. It's plotted against the same columns. So in the first cell here which I am pointing, you can see that sepal length is plotted against sepal length, so that will give you the distribution. So here you can see that the diagonals will give you the distribution. So since all the diagonals are numeric variables and it's continuous, you are getting a graph like this. And the final one, the species, it's a category, that's why you are getting a bar plot like that. Okay, so here from the shapes you can see that these two are very much normally distributed. The mean and median kind of showed a similar variation, similar values for the case of petal width also, but when we plotted it, it's looking like this. Okay, so from the plot we can directly see which are the variables that are normally distributed. Okay, so you can take these both these. Okay, and the other thing here, it is showing the how the variables are related. The correlation graphs are present here and the values are present here. Okay, and these plots, I think, I don't know if you have learned, these are the box plots. So box plots will usually show the variation as well as if any outliers are present in the data. Okay, so here you can see this box plots were also told earlier in the earlier lectures, I think. So box plots are also drawn in this particular thing. So this is the whole pair plot. Okay, so I hope this is clear till now. Okay, yeah, so that is the plot. Okay, so that is the question. So second question we have solved. Now the third one is like, so this is just the how you will see the difference. Okay, so you have to check what is the mean and median values. Okay, from the summary. Okay, now how many rows in the data set contain missing values? Okay, so for that you have to go with this particular command, that is na. Okay, so that means that it is checking for is it not applicable. Okay, which means that usually this is how the missing rows are identified in Python as well as R. So if you are getting like a not applicable in one of the rows, then it means that there are missing rows present. Okay, we have looked at this earlier, so directly we will go there. Our data frame is iris_data. Okay, and so I will just bring this down. Okay, so our data is iris_data. All right, so in this I am just putting is.na. Okay, so is.na of iris data. So this, if you run like itself, it will show you true or false where the na values are present, where the missing values are present. Now I am just giving a sum of this one because we are asked about the total number. So I am just putting sum of is.na of iris data. If I run this particular thing, I will be getting a 0 value. Okay, so that is known as how to find the missing values or rows in the data set contain missing values. So here right now there are no rows present. Okay, so this answer is 0. Okay, so I hope it is clear till now. The next, this is the answer for that. Now what can be interpreted from the plot shown below? Okay, so this is a plot given in the question. Okay, you have to interpret any of these 4 arguments given there. So you can see the plot given here, sepal length in centimeter, sepal width in centimeter, and all 3 classes are given. Setosa, versicolor and virginica, all the three are given. So from this you can check all the options. You can just check the figure. I think the figure is visible. Okay, and just tell me the answer. So what can you see? First we will check. First thing is sepal widths of versicolor flowers are lesser than 3 centimeter. So versicolor is given by green. Okay, so for green the sepal width is given in the y-axis. So if you see the sepal width, you can see that it is distributed between 3.5 and till 2 it is going, right, for versicolor. So it's going up to 3.5 also. So the first statement, it's not lesser than 3 centimeters. So the first statement is wrong. Okay. Yes. Then the sepal lengths of setosa flowers are less than 6 centimeters. So setosa is given by red. Yeah. And the length is, okay, the 6 length mark is going like this. So you can say that this statement is true. Okay. Now sepal length of virginica flowers are greater than 6. So virginica is here, sepal length. So some are falling below 6. So that is also false. And sepals of setosa flowers are relatively more wider than versicolor flowers. So setosa flowers, sepal width is like this. So sepals are relatively more wider than versicolor. That is also true. Okay, isn't it? Sepal width is here. Okay, so this also you can just tell, since it's given relatively more wider. Okay, so answer is B and D. So based on the given plot, it can be seen that setosa flowers have wider sepals compared to versicolor and virginica. Also, sepal lengths of setosa flowers are less than 6 centimeters. So the answers are B as well as D. Okay. Yes. So now next, back to the code. Actually, which of the following code blocks can be used to summarize the data, finding the mean of the columns, petal length and petal width, similar to the one given below? So we have to form the answer like this. So I think you can expect questions like these in your exams also, just giving the problem and how to find out the ways in which you can arrive at that answer, okay, based on a data set given. So okay, yes, what Sumit, what is your question? What type of question? We have to write code. How much you have to write code, I am not very sure, since in your pattern it's given you can have multiple choice as well as essays also. Okay, it's not, the pattern changes every time, it's not decided by me. Okay, it's we are just the TS assigned to this. Okay. Okay, Sumit. So I think it's better you be aware. No, code compiler won't be there. Only you'll be having the questions only. There won't be any what you say that compilers given for you. Okay, or our studio won't be available. That is what I'm hearing. You just have to ask in the discussion forums also for clarity. Okay, Sumit. Yes. Okay, yeah, Swami has given A and C. Okay, L apply iris data. Okay, so we'll see each one by one. Okay, so for those who haven't got the answer, we will see. So here, that is the question 5. Okay, so first we will look at the D option. So D option is apply iris underscore data 3 column 4. That means the petal length and petal width are available in those columns, right? And it's given 1 comma mean. Okay, so I'll just run this one. So you just first will look at this one. This is the third column and this is the fourth column. So if I run this particular thing, what am I getting? So I am getting the mean. Okay, So it gives the mean values across the column for each and every row actually. Okay, so whatever rows are present, it will give you that value. Okay, so if you want to do it the other way, like if you want to get data with in this format, like petal length is 3.75 and petal width is like that. So this is like we are taking, so this is iris data, this is the column petal length. So for all these rows, the values, the mean should be coming from this whole column, then mean should be coming from this petal width. So for that you have to change this particular apply to another format. Okay, so the fourth option was that. Okay, now we will just see what happens if the same thing is given like this. 2, because 1 denotes row, so row wise it has calculated the mean. We will just see what the 2 represents. Okay, so now you can see when I just gave the same command with the number 2 here, that means it should be taken column wise. Now you can get the same answer. So this is answer C. So that is one of the answers, that's true. Now you can see the B option. Okay, so the B option is S apply iris underscore data like this and like this. So what can you tell me what will happen there in that particular case if I run this one? Have anyone done that? So I'll just run this one. Okay, so it will be coming error in match dot function. 2 is not a function, character or symbol. So first, if you want to see it clearly, you can go for the F1 actually. So all the functions are given there. Okay, so in this S apply you are given like x comma f, then simplify and use names equal to false. Okay, so there is nowhere place that mentioning that you can give the row or column wise thing, so that's why an error is coming. Okay, so the same option, if you are just removing this thing particular thing and you are giving just the mean, okay, then you will be getting the same answer. Okay, so you can see that this particular option S apply with number 2 and mean is wrong. Okay, so this is wrong and this also is wrong. Okay, we have already seen you have to change this to, this one has to be changed to 2. Now we'll look at the option A. So option A, you can see here L apply iris data 3 to 4 mean. L apply is another method that you can use. It returns a list of the same length as S, each element of which is the result of applying function to the corresponding element of X. Okay, so what can you do? You can just run this one and you can see that for each of the columns it is giving like this. Okay, so you can take that particular option also. So for this particular question our answers will be these two, A and C, as Swami has given. I hope the others are also clear now. Okay, so I have given the answers of every method there. Okay, you can check it later. Alright, if anyone has any doubt they can ask. Okay, otherwise we'll be moving on to here. Okay, so this is just a direct question. Which of the following packages must be imported? Okay, so GLM, that you will be using for logistic regression. Okay, lapply is giving in list form for you. Raghu, when you tried lapply is giving in list form. Okay, that means what do you mean by that? Are you meaning like it is giving? Okay, yeah, yes, you can just tell that it's just first similar to the one, it's not given same to the one given below, no, it's given similar also. Okay, that's why you can just tell like these two things can come, these two options can come. It's not like telling like this should only be the answer, it's not telling, it's telling similar. That's why we are taking the two options. Otherwise, yeah, otherwise it should be this option only. Okay, yeah, you are true with that, but still since it's given, yeah, similar means not all, it's not like that, like this or similar to this one, the answer should come like this. Okay, so one of the options it's giving like directly like this, the answer comes like this itself, or it should come like any other way. Only thing is like it should calculate the mean for that particular column, that only means there. Okay Raghu, is it fine? Yes. Okay, now yeah, GLM, this function you have already seen in your lectures. So it's like for this one, it's a logistic regression function, it's an inbuilt function available with R programming. So none of the above is the answer. Okay, for that particular thing, these are not the packages that you need to install. Okay, next one, encode the dependent variable species, split the given dataset iris dataset into training and test sets in the ratio 7:3. Okay, so first they are giving like the encode. So species right now is given like what? It is given like three things actually: Setosa, versicolor and virginica. Okay, so they are telling us to encode the dependent variable species. Okay, then another next step is to split the data 7:3. Okay, like 70% train and 30% test, and put a seed value as equal to 123. So I think you are familiar with the seed value. Okay, otherwise it is like a parameter, okay, which will which will give you reproducibility of the results. Okay, for example, if you are giving like getting like the accuracy as 98% one time, next time you run the code also it should give you the same result. Okay, so in that we will have to set the seed or the how the random numbers are generated. Okay, so if you give this particular seed number as this particular value, then for that particular value you will be getting a result. If this is any other number, so usually we will be seeing like 0, 1 or any other value, you will be getting one set of readings. Okay, so these values can change, and if you are setting it to a particular seed number, then every time you run the code it will be coming as the same number and same results will be coming. Okay, so these are the steps that we have to do. First we have to encode, then we have to split into training and test set, and with the seed value 123, and after that we have to see the different different questions. Okay, following that, so first this is the iris data. Okay, so once more I'll load it clearly. Okay, so iris data, this time I have given file.choose. Okay, so I'll just click on that and iris data is loaded, right? It has 150 observations of 5 variables. So in this particular thing, when I have loaded it, I just gave header equal to true, row names equal to IDs, and strings is factors equal to true also I have given. Okay, now library CA tools that I have installed, okay, for split. Okay, now just wait a moment. Okay, So here you can see I am setting the seed. Okay, so first when we read here itself, the species are taken as factors. Okay, so factors means that it is taken as categories. Otherwise, if you are not giving that particular statement, it will be read as characters. Okay, so just I will show you that difference. Okay, so I have removed that and then just taken the same thing. Now when you see here, you can see the column 5 written as character. Okay, so character means it's just recognizing the species column as a character. That means it doesn't acknowledge that the species is a categorical value, categorical column. It's just recognizes it as a character. Okay, so either we have to convert the species as a character, using as dot factor, or otherwise what you can do is at the beginning, at the read, when it is read itself, you can mention that it should be read as factors. Okay, the strings should be read as factors. So the strings as factors is one way where you can change it to categories. And if you just tell that setosa equal to 1, if you just mention that, then you can encode it as like that itself, like 1 2 3. Okay, that is not needed here right now because already it's taken as factors. So this thing we are directly encoding as factors, so you don't have to do any further things in that. Okay, so the library is already loaded, and anyway I'll just set the seed once again as 1 2 3. So two steps are over. Now we just have to split the things. Okay, so what I am giving is that I am just sample dot split. Okay, I am taking and iris dash according to the species. So we have converted it as factors, that is why it will be now categorizing based on that particular column. Otherwise, if you are not giving that particular column, okay, so right now I will show the differences. So if I am just giving without, so I will just give iris 1 and I'll remove the string as factors equal to true. So I'll read that the same file to here. So iris 1 is here right now. Iris 1 is stored as a species, in the species as a character. Now I'll just do the same thing. I'll just do the same thing, and instead of this one I will give 1. So if I do, it is like coming 1 to 50. Okay, just if you just see here, it is coming like this itself. Okay, sorry, what did I do? So if you are giving like that, it's coming like false true like that, or it's coming only. Okay, now we will see the other one. So here next time we will see like iris data underscore species, and then we will see wherever the data is coming. So for character also that is true. Okay, in character also if it's there, it can be done like that, but in the question we were asked to categorize it or to encode it. Okay, so wait, just I'll do these 3 together. Okay, so you can see here split data true coming like that. Here also when we were giving the thing as character also, it had come like that. Okay, so that doesn't matter there. So now you can see train underscore iris underscore data, it is a data frame with 105 observations. So wherever the true has come there, it has taken and stored in train underscore iris underscore data. Okay, and so here one other thing that you have to see is iris data here is like factor with 3 levels. Okay, it's there. So it has splitted like that. Okay, so wherever true has come, it is in train. Now we'll just see the dimension, but already you can look here as it's showing 105 observations. Anyway, if you just see, it's giving 105 and 5 columns also. Now again we will see like it has randomly split like true and false for the different rows, right? So wherever false is there, we will give to the train test set. Okay, so here you can see the test iris set, it also has factor with 3 levels. Then test iris set I also have already have taken. The train iris also has a factor with 3 levels. Okay, so since it was asked in the question that we have to encode it, that's why, just wait a moment, that's why we are giving like that. Okay, and okay, so that is the answer. Okay, I have gone, okay, yeah, sorry. So we have reached till here. Now what I am doing is like encoding. Okay, so right now we have done the factorization as different things. Okay, so what I am doing is like independently I am doing for the train iris data as well as test iris data. So first I will do for that, I am taking this particular train iris underscore data and the column species in that. Okay, so train iris now is looking like this. We will run this particular line. Okay, now see again train. So now you can see species. Now it has come like numeric with range 1 to 3, but you can see it is like wherever one particular class was there, it is 1, wherever setosa was there, then 2 and 3 will be coming. Okay, so all the 3 steps are done. So similarly for the test iris data, then we are converting it as a numeric. That also will be coming like 1, 2, 3 like that. So I hope it is clear till now. Okay, so we have done these options, these 3 things we have done. Now we have to look at which of the following parameters are significant with 95% confidence interval. Okay, so for these things now we have to go look at the model. Okay, so since as you have learned GLM, okay, that we will be doing. Okay, so for that particular thing, it is like fitting generalized linear model, for that we are using. And okay, so GLM is used to fit generalized linear model specified by giving a symbolic description of the linear predictor and description of the error distribution. So everything around that it is given here. So you can see here logit model I am giving. Okay, GLM of this formula is like species is the dependent variable, then it is based on the other variables like sepal length, sepal width, petal length and petal width, because in the question we are asked about these 3-4 variables. Okay, so for every question it's not required that you have to give all the variables. Sometimes if you exclude 1 or 2 variables also, you will be getting a higher accuracy. Okay, so in this case we have to find out which are the significant parameters. So for that we will run this particular thing. So data is from train iris data, because we are not touching the test data right now. Test data will be used for prediction. Okay, so train data is where you will be training your model with. So for that I am giving logit model GLM, this particular equation which will show that every other every variable available, every column available is included in that, and then I will be looking at the summary of the logit model. So the summary will show you like this one. Okay, so all the details about all these things available, things given were given in the lectures also. So we will look at the specific one needed here. So the question was like, which following parameters are significant with 95% confidence interval? So 95% means that it is like this star, okay, 0.05. Okay, 95 means 0.05% is the confidence. Okay, I mean like 0.95 is the confidence interval. So you can say look at this particular thing. Okay, so 1 star shows that the level of significant code is like 0.05. So here you can see petal width and the intercept also is given with 3 significant codes. You don't have to see that. Petal length is having like 0.05. So with that particular significance, petal length and petal width are available. Okay, so you can see that with 95% confidence interval, those are the two variables available. So here you can see how to convert it to the available thing. Okay, so what I have already mentioned, and this is the thing that you are seeing in the RStudio. Okay, now from the given summary it can be observed that petal width, petal length and intercept. Okay, so you can see here the one which is having directly 95% is the petal length, then the petal width is also there significant, and intercept is also significant. So from the last class you might be remembering that if it is significant with this particular level of significance, that means that the null hypothesis is ignored there. So if the null hypothesis is ignored, that means that the coefficient with respect to, for in this particular case, the coefficient with respect to petal width is not equal to 0. That means that petal width is important in this particular model. Similarly, since the significant level is given like 95%, petal length is also significant. Sepal width is not significant at that level. It means it's like this one. Okay, so it is a very like low significance it has, and sepal length also low significance. Intercept is having a significance. Okay, so in this case you can tell like all the three, petal width, petal length and intercept, all these three you can give as the answer. Are there any questions in this one? So this is the result that you will be getting. If this type can record it. Okay, Sumit, they can just give you this particular data, right? They can give you this particular column like that. I mean, this particular data, this much part they can give you and ask you for the significance, right? Like other question was asked for the petal length and sepal length, how to derive at this particular answer. Like that it can be asked. Is it alright, Sumit? They can give you the code snippet. Yeah, I mean, this is how the output is coming, or you can infer something from that data. Okay, directly it won't be like you have to code and then you have to see the answer. Okay, so that we have solved. Then what is the coefficient of the variable sepal width in this fitted model? We'll go back to the thing. We just have to see the coefficient of the sepal width. Okay, so this is the coefficient of the sepal width there. Okay, so the answer is 0.13. This is the answer. Okay, now based on the snippet in the previous question, the coefficient of the variable sepal width is minus 0.13111. Okay. Now state whether the following statement is true or false. Logistic regression tends to overfit when we have a large number of independent variables present. Is it true or false? Okay, yeah. Anyone else? Yes, Hariom. Okay, yeah. So I think you have seen one graph showing you how many number of variables are required. Okay, so just if you plot the result with the number of variables, then and this also is applicable for the degree of polynomials used. So for this particular variables, okay, so if for a lesser number of variables, if your error is reducing, okay, yeah, then you can have, so in this particular graph, if you are plotting the number of variables used here, okay, you can see that you can stop at this particular level itself. That much is only needed, and you can just look at the significance also. So whatever variables are not significant, you can avoid. Okay, in other ways, like if your error is like moving, error is like going straight, okay, without any change for a large number of variables, you can avoid that. In some other cases, you will be having variables which are having interdependency. I mean, these variables might not be dependent with the target variable or the final dependent variable, but in some cases the columns might be having some dependency. That also you can avoid. Okay, that is not required because only one column from that is required to be used in the prediction. Okay, so in that case, if you use all the large number of independent variables, if they are present, it will lead to overfitting. Okay, an ROC curve is plotted between sensitivity and 1 minus specificity. Yes, that is true. ROC curve, okay, is plotted like, I mean, this is the particular curve. It is plotted between sensitivity, I think you might have seen it like SE, and specificity like 1 minus SP. Okay, so this you might have seen, and there is a 0.5 line here. So area under this line, okay, I mean, it is like AUC is 0.5, you might have learned. Okay, if your particular graph is coming like area under the curve, under the receiver operating characteristics, that is ROC, so if it is coming as 0.5, then you might have to rethink how you have named your variables as well as the models that you are using. Okay, so actually you should be having a higher value of AUC for your model, maybe like between 0.9, if it's 0.9 to 1, if the AUC value is like 0.9 to 1, it is a very good model. 0.8 to 0.9 also is accepted. So in that cases and all, if it's a very good model, it will be going like this. Okay, so that is for the ROC curve. You can refer to the lectures also. So an ROC curve can be plotted between sensitivity and 1 minus specificity, or it can be told as the true positive rate or false and false positive rate, determining the best classifier that actually predicts the classes. Okay, so then some practice questions. Which one of the following is called as the odds ratio? Okay, ratio of probability of an event occurring to the probability of the event not occurring. Okay, everyone is telling A. Okay, so if you are taking like P of S, P of X as the probability of event occurring and the probability of event not occurring as 1 minus P of X, then P of X by 1 minus P of X is the odds ratio. That is true. Okay, so answer is 1. Now in the confusion matrix, the misclassification rate is given by, so for that just I will brush through what is the confusion matrix which you have seen earlier. So if this is the true value, or here you will say like the reference value, so reference positive and reference value negative, then in this place you will be getting like predicted values and predicted positive and predicted negative. Okay, so this is the matrix that you'll be looking. So this is like two classes are only there. Okay, either yes or no, like it's a binary classification problem. So if you are getting like predicted true as well as reference also true, it is like true positive, and reference negative and predicted positive. Okay, so you can tell. Okay, Swami is giving us A. Okay, anyway, okay, you can say like that. So here this is, first we will see the true ones first. Predicted negative is the true negative. Okay, predicted and reference negative. Okay, so this is coming in here, it is coming like prediction as positive but it is false, so you can say like false positive. And here you can say like the prediction is coming like negative but it is actually positive, so you can say like it is like false negative. So misclassification you can take as this one. Okay, the right classification is along the principal diagonal, true positive, so that is taken by the accuracy. Accuracy means true positive plus true negative by the total number n. N includes TP plus FP plus FN plus TN, that is accuracy. Misclassification rate is that what all are misclassified. So misclassification is FN plus FP, that is false negative and false positive by the total number of samples. Yes, so that is true. Everyone has given the right answer. Okay, now the value of both sensitivity and specificity lies between. What can you say for this answer? Okay, D. Okay, that is also true. Okay, because won't be coming as negative anyway, it's a number. Okay, what is sensitivity? Okay, I'll just give as E. How many positive things are identified, right? So that depends on how many are totally positive there. Okay, and from that, can you tell me? So total number of positive samples are, one thing is true positive anyway, it's positive samples, and falsely negative given also is total number of positive samples only, and from that true positive is the sensitivity, and specificity is like the negative one. Okay, so in the negative one, if you see the reference, negative things are like this, true negative and false positive. So the total negatives from the true negative and false positive. Okay, just look at the matrix. First draw the matrix, and then if you look at this particular thing, I think I can change the color. Okay, from this, if you see, this is the total, these are the total things which are given as positive, and from this how many are identified positive, that will be giving you the sensitivity, or sensitivity means the ability to get positive readings. Okay, positive, identify something as positive, so that means from this one. And the ability to identify something as negative from the negative samples will give you the specificity. Okay, so I think that's clear. Any doubts you can ask, otherwise next question. In logistic regression, a linear relationship is assumed between the independent variables, and so we are assuming in logistic regression, we are doing an assumption. We are assuming a linear relationship between, okay, there is one simple catch there in the question. Okay, actually you will be taking the sigmoid of the, okay, Naga, you just see the choices once more. Are you taking the sigmoid of the dependent variable? We are just taking that, but we are first assuming a linear relationship. Okay, log is taken between, for the ratio, okay, log of p of x by 1 minus p of x is taken, but that is the probabilities. Okay, just first a linear relationship we will be assuming between independent variable and the dependent variable actually. Okay, these are all the calculations present. First we will be assuming that our dependent variables and independent variable are having a linear relationship. So in this particular case the answer will be none of the above. Okay, is it fine? That is the first assumption that we will be doing, then only we will be moving. So if our assumption or when we are observing the data distribution, data looks like having some non-linear relationship, we will move on to other classification methods. We will not go with logistic regression. Okay, so only if your data, the dependent variables and independent variables are having a linear relationship, then only we will be going for logistic regression. Okay, then I hope that is fine. So first as a linear relationship we will be assuming, then only we will be going forward. Is it clear? Okay. Now the confusion matrix for a binary classifier gives, you have already seen this one, you can directly answer. Yeah, this is right. True positive, false positive, true negative and false negatives. Okay, so now we will be checking as the previous course questions. So earlier questions was taken the course before the previous course. Okay, so now the previous course questions. So first one is, which among the following is not a type of cross validation technique? So you have seen the different cross validation techniques. Okay, so first one you have seen is the leave one out cross validation. So as you have seen in your slide lectures also, it is the type of a cross validation approach in which each observation is considered as the validation set. So for example, if you have, for example, I am considering this as the block, okay, like having like this many number of observations. So first you will be leaving one out and taking all the rest as the training set. Okay, then you will be taking this particular one and taking all the rest as training set. So that means that it is like leave one out cross validation. Okay, so in this one, when each observation is considered as the validation set and the rest is considered as the training set. Okay, then fitting of the model is done and predicting using one observation validation set, that is LOOCV. Okay, now k-fold cross validation means, so sorry for the typo there. So k-fold cross validation means you have some particular data, and in this data you will be dividing it, like for example I am just dividing data like this. Okay, different folds are there, 1 2 3 4 5, right now 5 folds are there. These are the different distribution data. Okay, different data points are there. So in this one I am taking one fold which contains different set of observations. Okay, here this cell meant only one observation was there. Here there are some n observations here. Okay, and total number of observations maybe you can take as capital N. So I am taking the first fold as the validation, and later the other things I am taking as the training set. Okay, so K refers to number of groups that the given data sample is split to. So I am splitting the data sample into k folds, and for each fold then I will be taking. So this is known as k-fold cross validation. So usually you will see that k is either 10 or 5 is used. Okay, usually. The next one, validation set approach. It's a type of method that estimates a model error rate by holding out a subset of data from the fitting process. This means that separately creating a testing data set, or like creating train, validation and test set from the data. Okay, and you are splitting the data first to 3 different data sets, and then using those observations to find it. Okay, so that is validation set approach. And next one, bias variance trade-off. So this is not a cross validation technique, so directly you can just give it like which among the following is not a cross validation technique. The answer is bias variance trade-off. So this bias variance trade-off means if the algorithm is too simple, then it may be on high bias, meaning like hypothesis with a linear equation. If the algorithm is too simple, then the model might be on high bias and low variance, and in that cases it is error prone. Then if the algorithm fit too complex, you have seen that in the lectures also. So if you having high degree equation, okay, maybe if you are considering the case for linear regression, and if you are using a polynomial with very high degree, then it means that it is having a high variance and low bias. Okay, so in the latter condition, what will happen is that the algorithm will fit perfectly or too perfectly, meaning like it will be overfit. So what in the case of overfit, what happen is that it won't be generalizing well for the new entries. Okay, so you are training your model on the train set and it fits perfectly for the train set, but what happens for the test set is that when new entries come, it will not perform well. So in that case the error will be very high. So there is something between both of these conditions known as trade-off or bias variance trade-off. So this you have seen with the example of a graph also. Okay, so this was the graph that you might have seen. So the total error which can be calculated can be taken as a bias square plus variance plus irreducible error. So this irreducible error will be there no matter what is the number of polynomials that you are taking, degree of polynomials taking, or what is the number of variables that you have taken in the case of classification. So you can see here the bias squared is decreasing very much, and if it's decreasing so much that the model is so overfit, then the variance increases in that case. So there should be some trade-off. So in this particular area, in this middle area, your model complexity should be. So model complexity means in the case of a linear regression problem, it will be like the number of the degree of polynomials should lie in this particular region, If it's in the case of a logistic regression where it is a classification problem, it will be like the number of variables that you have taken. The number of independent variables should be like it is in this particular region. Okay. So this is the bias variance trade-off. I hope that's clear. Okay, we'll move on to the next one. Which of the following is a classification problem? Predicting the average rainfall in a given month, or predicting whether a patient is diagnosed with a disease or not, predicting the price of a house, or predicting whether it will rain or not. Yeah. Anyone else? Okay, everyone is right. Okay, so the first one is a regression one. Okay, regression type problem, first one. Second one is a classification problem. Predicting the price of a house is also a regression problem, and predicting whether it will rain or not tomorrow, it's just like a yes or no condition, so that is also a classification problem. So you can tell these two, B and D, right? So next one, consider the following metrics for the classification of a hatchback and SUV. So hatchback and SUV, it is like the data set which you have seen in your particular lectures. Okay, I think you are familiar with that. Anyway, we are given with the confusion matrix which is available as a result. So this is the true conditions and this is the prediction. You can tell me the accuracy of the model. So the total number of observations is 100 here. Okay, everyone is giving 0.95. Yes. So what is accuracy? You have to take the true positive plus the true negative by the total number of observations. That means that 55 plus 40 by 100, that is 0.95. So answer is A, that is true. Now find the sensitivity of the model. I have already given you how to calculate this one. Sensitivity is given by, you have to identify what all are positive. So positive means true positives are already there plus the ones which were classified as negative from the two positive. So okay, what is the answer? People are giving as C. Why? Because 55 plus 0 by 55, right? So it's 1, that is true. Now under the family parameter of the GLM function, which one of the following distribution correspond to logistic regression for a variable bit binary output? Okay, A, binomial. Yes, that is true. It's directly from the theory. Okay, binomial distribution. Okay, so we will move back to the R Studio. So just if you want to see the different things about the logic model or the GLM function, you can just click on this link, okay, and just go to that particular site. So I'll just show you that. Okay, this site has all the different parameters available about the GLM function. It has different parts also. Now we will move on to a different type, same with the same data set only. Okay, so the iris data set, anyway I had shown that available in like this. Okay, this data set is like this. Okay, but in case you are not getting it, it's already available as a data set in RStudio itself. Okay, so just I'll run this one to remove everything from the environment. Okay, And just what you can do is directly library of datasets. If you load all the pre-available datasets will be loaded here, and in that just you have to type iris because it's stored as in the name iris. So iris data, I am storing it as AR underscore data. Okay, so here I didn't give any specific condition for loading it, so here it is taken like numeric, then sepal width as numeric, petal length is numeric, petal width as numeric, and species factor with 3 levels. It's coming like this. Okay, so it's already like that. Now when I loaded it from my system, I had given all these different arguments inside that particular read CSV. Okay, now I want to see the samples. This we have already seen. Head, if you give, you will see the first 6 observations. Then tail, if you give, then also you will see the 6 observations, and sample will give you some random sample of 6 observations. That is true. Then if you want to see the structure of the data, you can see numeric, factor with 3 levels. Okay, and this we have seen already, finding the missing values. Okay, so now what we'll do is that just see for 2 species only. Okay, earlier we have seen for 3 different species, and we have calculated the model using the GLM function, and we have seen the summary. Now what we'll do is that we will just see it as a binary classification problem. So for that I am just seeing it for only 2 species. So I know that the first 100 observations, okay, till the first 100 observations, you can just see here only versicolor and setosa is coming. Okay, so this particular data set is distributed like the first 50 is there. Okay, the first 50 is setosa, the next 50 is versicolor, and the next 50 is virginica. That's how this data set is distributed. Since I know that, what I'll be doing is like I am just taking the first 100 observations. So I'll be storing it to IR data. So 100 observations are really present right now. Now I'm just defining a seed as we have seen earlier, and then sample from that. Okay, so 80 readings are given in as the train set. So for that I'm just giving, so sample means some random sampling for, so it's, you can see here 74, 89, 78, like that indexes are there. So some random indexes are taken from the IR underscore data, and I am just giving IR underscore train from that. So some 80 observations are taken. Similarly, I am giving like minus sample. So minus these indexes I am taking as a test. Okay, so this is a different type of sampling. Earlier we have seen in this way also, we have used sample dot split in the ratio we have given. Okay, so if you have to split like that in that particular ratio, you can take that. Otherwise you can take in this particular level in this way. Then just seeing the dimension, it is 85 and 25. Okay, now just this we have seen earlier, for plotting we need these two. And when you see the GG pairs, earlier also we have seen, but right now there are only 2 things. Okay, there are only 2 classes. So you can see here, there are only 2 classes, setosa and versicolor are only present. And with these 2 readings, how are the relationship? Okay, now you can see the sepal length is more normalized. Then based on the plot, we are applying the logistic regression. Okay, so just I am giving y equal to train species, train dollar species. Species is saved to the y variable. Okay, and to the x variable I am giving just the sepal length. Okay, so Earlier we considered all the independent columns. Right now we are just seeing the y, which is the dependent variable, and x as the sepal length. Only these two are given. So with these two I am forming the model. Okay, then family I am giving as binomial. So this will be your answer to the question which was asked earlier. Okay, so I am fitting the model GL fit. Okay, this particular GLM model. Okay, and if I give summary, you can see that only x is coming. Okay, and the intercept is there. You can see the significance levels for 0.001 significance level itself. These are significant. Okay, so these both have to be taken. So this is the summary that you'll be getting. Anyway, so now you have to predict whether a new data is either what you say is like you have to see whether it is correct or not. So we'll be using the predict function here to see whether the model you have built is a good model or not. So for that, what I'm doing is that I have already split the data as IR train and IR test, and in IR train we have done this particular, we have trained this model. Now what we'll doing is that I'm just forming a data frame with IR test, and predicted value I'm giving predict GL fit, then new data is our test data, and type response I'm giving. And if you see the prediction, okay, so predicted value is like that. So if I am just giving it, if I am just forming the predicted value, so predicted value is storing something. Okay, we will see what it is. So it will be storing the probabilities. So I am just forming a new data frame with sepal length, that is anyway our x parameter. Then IR underscore test species is the y parameter, and predict underscore value is the new predictions which are done. So if I do that, and if I just print that, you can see here sepal length, which we have taken as the x variable, then IR underscore test species, this one, and the predicted value from that. Okay, you can see 0.5212, 0.83, 0.99. So higher probabilities are also present, lower probabilities are also present. So what we'll do is that, okay, so the same prediction I'm changing it to some other new value. Okay, so pred new I'm giving, okay, just seeing it, and I'm giving it like that. Okay, so another new data frame. We still have the prediction data frame also. So in this pred new, what I'm doing is that the predicted value, which is having the probabilities, wherever it is less than or equal to 0.5, I am giving the pred type as setosa, and wherever the prediction value is greater than 0.5, I am giving it as versicolor. Okay, so I am giving some things because we are only having the probabilities here. We want to find out wherever it is coming, the prediction is coming. Fine. Okay, then if I just print the new thing, you can see that everything is there. Okay, so the length is there, species setosa, prediction is coming like versicolor. So this is a wrong prediction. Setosa it's coming. So in other case, in these two cases, okay, setosa was predicted as versicolor. So some misclassifications are there. Okay, now what I can do is like I'm just doing a new data frame with the columns as sepal length, species, and the pred new $pred type. Okay, so if I run that, you can see that just the probabilities have been removed, and we have three columns like ir.test.sepal.length, ir.test.species, and pred underscore new .pred type. Okay, so if I see how this is looking like, you can see that this sepal.length, that is a numeric variable, and species is a factor with respect to 3 levels, and pred type is a character. Okay, you can see here it is also given like 3 different columns, 3 different categories are there, but the data frame has not identified it as a category. It is just identifying it as a character. Okay, so when you are doing the confusion matrix, one thing you have to make sure is that both the reference values as well as the predicted ones should be as a factor. Okay, otherwise it can't be compared. Okay, so I'll just include this library for the confusion matrix, that the library is included. Now from the str of pred class we found out that the prediction right now is like a character. So I'm just first creating a confusion matrix with this. Okay, so what I'm doing is like, it has to be as a, either these both has to be same, either this should be both factors or either these should be both characters. Okay, data types should be similar. So example, I'm just storing into a new variable. So confusion matrix data equal to pred underscore class pred type. Okay, so I'm giving this such a long name because you can see here pred underscore new dot pred type is the column name there, and it is the column of pred underscore class. So that is the thing, and the reference value is pred underscore class ir underscore test dot species. So between these two I am forming the confusion matrix and storing it to example. So here you can see data and reference should be factors with same levels. Okay, so either what you can do is like, either you can convert it to a factor or you can convert it to as character. Okay, so first we'll do one type. Okay, so I'm just converting species as a character. Okay, and then I am running the confusion matrix again. So first we'll see it again. Str of pred class, you can see now both characters are there. Now you will be seeing okay, now if you see pred underscore ir dot test species is right now as a character, and again if you run the confusion matrix it is coming like this. So it is given like it should be factors with same levels. So what I'll do is like, I'll just be giving pred and reference both as, what I'll say, I'll convert it to factor. Okay, so earlier, just I will read that once again. Okay, so what I can do is, I load that and then give this one and this one. Okay, so what I'll do is, I'll just run the whole thing first and come back here, pred new, and this is because I have converted it to character earlier. Okay, so first if I do that, they are telling like it should be factors with same levels. So what I'll do is like, already species is a character, I'm changing the other one also as a, so it's a factor. Okay, sorry, ir underscore species is a factor, so I'll change the other one also as a factor. So okay, so this is the thing, pred underscore new dot pred type, pred underscore new dot pred type, I am converting it as a factor. Okay, so if I run that, and again I am seeing the different thing. Okay, so sorry, okay, I didn't do like that. I didn't make any changes in the data frame, just I have stored it as pred. Okay, so pred dot as factor I have given. So here you can see pred factor. Okay, factor with 2 levels only right now, because we had taken up to the first 100 observations only. Now reference Reference you can see also as a factor. Just I am seeing the length once more. Okay, both are 20. If the length is also different, there will be a problem, error coming up. So then I am just giving. So confusion matrix is usually like you have to give the data value, you have to give the prediction as well as the reference. So data will mean the prediction that we are making. So it's given like pred, and the reference is given like ref. Okay, so if I run the confusion matrix, the warning is coming, but still if you do that, you can see the matrix. Okay, so right now you can see earlier it was stored like Virginica was already there, but it is 0 0 0 coming up. You can just look at this particular these two things only. Okay, Setosa, true positive 7, true negative 8, and these things. Okay, so accuracy 0.75, all the different values are there, specificity, sensitivity, all these values you can see there. Okay, so any other questions in this particular thing? So if there are no other questions, then I was just thinking like we will just look on for some things. Okay, like since you are just looking at the logistic regression as well as linear regression in this week, and the next week you will be looking at KNN, right? KNN, like cluster analysis, and KNN classification also. So I was just thinking like this week I'll just give you the theory about some other classification algorithms. Next week we'll see the RStudio implementation also. So I'll just explain with the help of notebook. So I have logistic regression, you have already seen it. Okay, so I'll just be looking at support vector machine as well as decision tree. Okay, and next week we will be seeing how to implement those in R. Okay, so SVM classification or support vector machine, I hope that is okay, and I hope there are no other questions, right? If there is any other question, I can answer that and then move on to this one. Don't you can ignore the code there, that is in Python only. Okay, so what I'll do is I'll just leave that, and then support vector machine is there. So it is a linear model for classification and regression problem. This is another linear model. You have already seen logistic regression also. So the idea is simple. The algorithm creates a line or a hyperplane which separates the data into two classes. Okay, so you can see that there are two different sets of problems. I just increase the size. Okay, so you can see two sets of problems are there. Okay, so our intuition is to find an ideal line between these two points or a hyperplane that separates this data set into red and blue categories. Okay, so you can see you can create many different hyperplanes like that which will separate that. Okay, so SVM is like you will be looking at an optimal hyperplane. Okay, we will find points closest to the line from both the classes, and these points will have a distance from that optimal hyperplane, and those are known as the support vectors. Okay, so we compute the distance between the line and the support vectors, and this distance is called the margin. Our goal in this particular classifier will be to increase that margin, to maximize the margin. So margin will be formed with the farthest, point which is closer to the optimal hyperplane. So here in this case it is this one, in the other class it is this one. So we will be trying to maximize this margin. So whatever hyperplane will give you the maximum margin will be taken as the optimal hyperplane. Okay, so SVM tries to make a decision boundary in such a way that the separation between the two classes is as wide as possible. Okay, so that is the case for a binary classification. That means there are only one class, yes or no class, or either one. So for in the earlier case we saw like either setosa or versicolor. Okay, now if the complex data set is very complex, and you can see that you can't use a simple hyperplane to just separate the data. So that is like a non-linearly separable data. If you are getting, then you can't draw a straight line to classify this data. Okay, so what you can do is you can either you can convert this data to a linear separable data in a higher dimension. So you can see that for this particular example it's like z equal to x square plus y square is given. So another dimension we are taking. So there is an increase in dimension here, which is another problem which will come later. Okay, so you can see that a new dimension is created, and when that new dimension is created you are able to separate that two classes. Okay, so now it is linearly separable. So the purple line, as you can see here, separating the data in a higher dimension. So this particular point line is like z equal to one particular value as k. So here you can get that particular plane. Okay, so that extra dimension is like a circle. So when you bring it back to the original dimension, it is like a circle. Okay, so we can classify the data by adding an extra dimension, and it becomes linearly separable. Okay, so finding the correct transformation for any given data set is not easy, but in the case of SVMs we will be using different types of kernels. Okay, so there are different kernels which we can use. So later when we will be looking at the kernels, we will see how to identify those things. Okay, so different kernels. So right now many people will be using a radial basis function for that. Okay, so normal kernels are there, linear kernels are there, which will see a simple straight line. Sometimes you have a radial basis functions. Okay, so different kernels are there. Based on that your classifications will vary and your accuracies will vary. Okay, so that is what is a support vector machine, and later next week we will see how to do. So this is in the case of later I'll give you this resource also based on Python. Okay, so next one is a decision tree. Okay, so it's used both for classification and regression. So they use the classification and regression trees. Okay, so for that I think I will look at this particular thing. Okay, so a decision tree is a graphical representation of all possible solutions to a decision based on certain conditions. Okay, so here you can see, here it's like there is a condition. Okay, so first you can see, like I'll share these links also. Okay, so what you can see is that there is a particular condition. This particular condition will be like one of your columns which are given. For example, if it's an iris data set, it will be like whether the sepal length or petal length is greater than this particular value or less than particular value. Okay, so if you are having, or sometimes you might be having data sets where your independent columns are also categories, that also is possible. So based on the data set which is given to you, you will be having one particular condition, and if that particular condition is true or false, there will be two decisions taken. Okay, so if a lot of your data or whole of your data, some data is like having this condition as no, then it will be like one decision, and if it is yes, then it will be another decision. Okay, so this is a particular tree. Okay, and this condition 2 also will have different classes. Okay, then you can use another condition, that is condition 2, to separate those two classes. And at the end, if you are reaching where further divisions are not possible and you are getting one particular class in this particular node and the other particular class in this node, then you can say that you have classified it correctly. Okay, so this is like an example where there are 3 different classes are there. Okay, and so you can see here one feature X, feature 1 is there, feature 2 is there, and labels are there. So the root node is the first node which will be starting with the condition 1. So feature 2, it's based on feature 2. Okay, so this is the feature 2. So if feature 2 is greater than 3, we are giving as one condition. So you can see lab 1, lab 2, lab 3 are the 3 different classes. So if that feature is greater than true, so you can look at here lab 1 4, there are no other values for lab 1. Then look at lab 2, lab 2 is having 3 as well as 4. Then lab 3 is having the values 1 as well as 2. So first we are giving us feature 3 is greater than or equal to 3. So you can see here if it is true, then one set will be there, and if it is less than 3, so less than 3 is only one option, then it is lab 3. Okay, so if this feature is false, then it will be coming like, okay, here also this one also there, 1 and 2 is there. So the feature 1 for that is Z, and values of feature 2 is 1 and 2, it will be classified as lab 3. Then you can look at the next condition. So one particular thing is eliminated, lab 3 is eliminated there. Okay, now we are we are left with lab 1 as well as lab 2 classes. So the first condition is true for both these classes. Okay, now we will be giving like feature 1 as equal to y. So feature 1 equal to y means lab 2 and lab 2 can be separated like that. Okay, so feature 1 equal to y, if it's true, then you are getting the class as lab 2, and if it is false, you are getting the class as lab 1. So now you can see that in this particular levels, this is the intermediate level, so all 3 classes are separated, right? So this tree has done that. Okay, so this is known as a basic behind the decision tree. So you will be forming different trees, and you can just, how to find that is given by the entropy. Okay, so later you can go through this and see how you are finding out. So for the values where the entropy and the information gain is given, so this is the case where more number of things are coming. So at the first level, when we saw this basic example, we can look at the condition and see how it is distributed. But now if you are moving to a higher problem where many different classes are present and feature 1 and feature 2 is like that, then you have to go for other methods like entropy or information gain to find out which is the correct division that we are making. So for each of the different divisions, okay, we will be seeing the entropy values, okay, and information gain values, and if it is higher, we will be going with that particular division. Okay, so all the details are given. So that is how decision trees are done. And this random forest is like a pack of a different decision tree. So this can be explained with this example. Okay, so you can see here, this is one set of tree. This can be called as one decision tree, and this particular decision tree is predicting as 1. Okay, then with different other set of values, okay, different other conditions, we are forming different other sets of trees. So this particular number of trees will be giving like number of estimators. Okay, so if you are giving the number of estimators, as in this particular case there are 9. Okay, So like that, different number of estimators or trees will be formed, individual trees will be formed. And what you will do in the random forest is like you will be seeing a tally of how many ones and zeros are identified by the decision tree. So if you are getting a 0, so for in this particular example, this decision tree as well as this one and this one is predicting as 0, and the rest are predicted as 1. Okay, so there are 6 ones and 3 zeros, so the higher number is for ones. So in this particular example, you will be predicting it as a how many number of ones are there. So the majority is for the majority voting, you can say, is for 1, and you'll be taking the result of the random forest as 1. So random forest is like a collection of large number of individual decision trees that operate as an ensemble. Okay, so that is a random forest. So in different particular case, if you see the classification on training and testing sets on random forest as well as decision trees, sometimes there is a case that your decision tree will be performing better than random forest. Means that much number of estimators are not required for the classification. So all these things will be depending on your data which is given to you. Okay, so I hope that much is clear. Is there any other questions? So the R implementation of these we'll see in the next week, because already next week you are having the k nearest neighbors and the cluster analysis. Okay, so after the assignments in that particular week, we'll be looking at the R implementation using decision trees, random forest. Okay, so I think it's fine for today. Anyone else having any question? Okay, I hope okay, then I hope everyone is clear with the things which were taken. All right, so thank you everyone, have a nice rest of the day. Okay, we will see you, I'll see you next week. Okay.